Dear viewers, welcome to Feral Finds, where truth meets mystery and reality intertwines with imagination. Before we begin the exciting video, please hit the subscribe button to stay updated with our latest content, and don't forget to like if you enjoy this type of content. The Moon is the Earth's only natural satellite, and it is the largest celestial body that illuminates our night sky. It is the only place outside of Earth that humans have set foot on. The gravitational forces of the Moon cause the tides on Earth. These movements may have been the driving force for the transition of marine life to land, and they also prevent the Earth's axis from wobbling, providing some stability to its climate. But there is a very valid question. Why doesn't the Moon fall to Earth? In the 17th century, the famous English scientist Isaac Newton wondered why objects fall to Earth, but the Moon does not. This unusual question paved the way for one of the greatest discoveries in the history of science, which made this English genius famous. To understand how he answered this revolutionary question, let's imagine if Newton took a ball and threw it forward with force. It's logical that it would travel a distance before falling to the ground, and the greater the force of the throw, the longer the distance it travels. If Newton could throw the ball with enough force, assuming no air resistance, the ball would remain in orbit around the Earth and never fall. This sufficient force to throw an object was later called escape velocity from gravity, estimated at 11.2 kilometers per second. This means that any object, if propelled at this speed, such as satellites, would escape gravity and remain in orbit around the Earth. Newton came to a profound conclusion. The Moon actually is constantly falling, like the ball, but its fall is not vertical like the ball's. The reason is its high speed, 3,700 kilometers per hour. The Moon descends toward the Earth due to the same force that dropped the ball, but at the same time, it moves forward at a high speed, compensating for that descent. Since the Earth is spherical, it remains in a constant state of falling without reaching the Earth's surface. Its orbit around the Earth, as we see it today, is merely a result of this fall. The Moon continues to fall toward the Earth due to gravity, but at the same time, it orbits the Earth due to its immense speed. This is why the Moon remains in its stable orbit around the Earth without falling onto it. This conclusion set Newton on the path to establishing the principles of gravity. He later developed revolutionary equations describing the behavior of gravity, which have been experimentally verified and are still used today. Thanks to them, humans were able to fly and reach the Moon. However, what if the Moon suddenly accelerated and started moving towards the Earth? The Moon's hidden plan to destroy the Earth by colliding with it would collapse upon reaching Roche's limit. The Moon itself would be torn apart and would never reach the Earth's surface. This might seem exciting and reassuring. By the way, for those wondering what Roche's limit is, it's a cosmic mechanics concept, the point at which gravity maintains the Moon or satellite's cohesion, but it's weaker than the tidal forces trying to tear it apart. In other words, the Moon cannot approach our planet closer than 18,381 kilometers before exploding. The tidal forces would tear it apart, scattering all traces of footsteps and flags we left on its surface, forming a ring of debris suspended above the Earth's equator. The ring, with a diameter of 3,700 kilometers, would make Earth the second planet in the solar system after Saturn to have a ring of beauty around it. But our ring wouldn't last long. The debris from our former Moon would rain down on Earth, resembling hundreds of thousands of asteroids falling on our planet, a process that would wipe out our cities entirely. And when the Moon begins its journey towards the Earth, its orbital effect on us would increase. However, upon reaching Roche's limit, Its effect would cause waves as high as 7,600 meters or 30,000 feet. Our world would be destroyed by tsunami waves engulfing our regions 10 times a day. Of course, adventurous surfers would find great pleasure in that. But on the other hand, it might be a solution to global warming. With the moon approaching, the Earth's rotation would accelerate. Our days would become shorter and shorter, and global temperatures would decrease. Global climate change would no longer concern anyone. However, the moon actually never approaches. Instead, it moves away day by day in its orbit around the Earth, escaping at a rate of 3.8 centimeters every year. The difference in the rotation speeds of the Earth and the Moon is the main reason for the Moon's distance. While the Earth completes one rotation about itself in just 24 hours, the Moon takes 29.3 days to complete one rotation. This significant difference results in the Moon drifting away at a rate of 3.8 centimeters annually. Another result is a slight slowdown in the Earth's rotation speed. After 100 years, the day would be 2 milliseconds longer than it is now. And of course, the question that arises here is, what if the Moon drifted far enough to escape Earth's gravity? Will the Earth really miss it, or will it pass unnoticed? Find out the answer to this question in this video. Throughout the ages, humans have had a close relationship with the Moon. The impact of this multifaceted silver satellite is evident on our various civilizations, whether in using its phases in calendars, its role in tides, or its relation to global navigation. But let's imagine our planet Earth without a moon orbiting around it. Naturally, our nights would be darker, and the term full moon wouldn't be a widespread concept in human languages. Our moon constantly moves and deviates from its path annually by about 1.5 inches, moving away from the Earth. This process results in a slowdown of the Earth's rotation. So, what if one night we looked up at the sky and didn't see the moon? The moon simply vanished today. Will we miss its presence? The moon's brightness at full moon is 4,000 times greater on average than the brightness of the celestial body Venus in the night sky. Therefore, in the absence of the moon, all our nights would resemble its darkness, the nights preceding the beautiful moon's birth, and this scene would cause stargazers to be greatly astonished. But you will realize the next morning how important the moon's presence is for life on Earth, and to begin to understand the interplay between Earth's rotation, the sun, and the moon. The moon has the greatest impact on the movement of tides on Earth, and without it, tide movements would decrease by 75%, jeopardizing the lives of many creatures, such as crabs, mollusks, and marine turtles that live in tidal zones, disrupting the food chain for many animals that depend on them for food. This process would threaten the ecosystem in all coastal areas over decades. We would begin to see a decline in the populations of many marine and terrestrial species. One of the greatest reproductive events on the planet occurs at the Great Barrier Reef. In November of each year, on the night following the full moon, coral colonies release millions of eggs and sperm along the extended coral reef, covering an area larger than the state of New Mexico, minutes apart from each other. Scientists are certain that the full moon plays a role in this timing, but the mechanism behind it remains a mystery. On land, animals like red-eyed tree frogs use moonlight as a signal to begin the mating process. After living most of their lives in the mountains, millions of these adult frogs migrate towards the shore. Then, only during the last quarter of the moon's phases, females release their eggs into the sea. Now, the moon may not hold much influence over human reproduction processes, but without it, one thing we equally share concern about would change: the weather. Tides, currents, and resulting cold polar waters mixing with warm waters in tropical regions. This works to maintain thermal balance and climate stability worldwide. Without the moon, weather fluctuations would be almost impossible. Thermal differences between the coldest and warmest regions on Earth would reach levels threatening life on this planet. But all we've mentioned pales in comparison to the greatest change the next millennium will witness. Currently, the Earth's axis tilts at an angle of 23.5 degrees, and this deviation is largely due to the moon's gravity. If the moon were to disappear, the Earth's axis would swing in any field between 10 and 45 degrees. Some experts predict that Jupiter might manage to keep the Earth's axis deviation under control, but even a 10-degree tilt could disrupt climates and seasons. It's hard to know what a tilt of 10 or 45 degrees would produce, but it's likely not conducive for most life forms on Earth. The presence of the moon is essential not only for life on Earth today, as experts believe it may have played a role in the origin of life for over 3.5 billion years. The moon is not just a beacon in the night sky. Its presence is pivotal for the delicate balance that makes life possible here. The moon is not just a celestial body orbiting the Earth, it is an integral part of our history and future as living beings on this magnificent planet. Please hit the subscribe button to stay updated with our latest content, and don't forget to like if you enjoy this type of content.